Okay, here we go. We conclude this chapter on grasping complexity with a few words of conclusion. The phenomena and problems we are concerned with are complex regardless of whether we ignore their complexity or not. So Mother Nature doesn't care whether you comprehend and accept the complexity or not. Whilst we cannot know the complexity of the parts of reality we focus on, the human environment systems that we construct to make sense of them must fit our observations. So this is how it works. We gather some observations, we build a hypothesis, we try to gather more data to test the hypothesis, to develop a theory, but the complexity is something that may emerge out of the data if you have sufficient data. Sometimes you need spatial granularity of the data to grasp complexity in the data, or sometimes you need temporal resolution granularity, right? So continuing to approach complex phenomena or problems as if they are merely simple or complicated may be the principal blunder of humankind in the 21st century. So this subtle difference that the author tries to make on complex and complicated, I'm not sure how useful it is for actually what we want to do, but we'll discuss as we go forward. Although it may be relatively straightforward to grasp what constitutes complexity on the most fundamental level, that is the rich, dynamic and nonlinear interaction between many elements, its manifestations are indeed astonishing and consequences seemingly overwhelming. Undoubtedly, complexity is a fundamental challenge for us to understand, explain and improve our sustainability challenges and the world. However, this challenge does not provide a blank check to disregard complexity. Quite the contrary, the realization that systems we are concerned with are complex, open and operating far from equilibrium prompts us to overcome our linear intuitions and unlearn much of what we have been taught in school concerning how to approach phenomena and problems, or at least learning when it's not appropriate, if ever. Well, that's just generic words, but you know what he means. Approaching such complex systems as if they are complex is essential for any endeavor to manage risk and resilience for sustainable development. So if you have data, you may know it's a complex system, but approaching it as a complex system means you have to have an understanding of what actions can deal with complexity, with all their surprises, emergent properties, complexities, intrinsic volatilities and God forbid tipping points and so on. Such an approach entails recognizing the importance of feedbacks and the disproportionality between the cause and effect it may give rise to, like increasing CO2. We didn't know how much warming a trace gas can cause, but now we know. So what do we do about it? We are negotiating the hell out of it, but still not reducing emissions as such. It involves understanding how interacting elements aggregate to form hierarchies of interacting systems within systems with emergent properties on each level that cannot be explained by studying the elements on the level below in isolation. So that's resilience. Such emergence is rooted in the interactions between the elements, and the emergent property may influence them. So the emergence itself depends on the interactions and the emergent property that the system possesses. Approaching a complex system as if it is complex entails recognizing path dependence, as past events both constrain and enable current events, which in turn constrain or enable future events. Basically, emergent system, even if you know all the past, it may produce a surprise. That's what we already said, right? It involves understanding that interactions between elements can result in elaborate organization without the involvement of a commander, controller, coordinator or creator, and that such self-organization exceeds organization based on centralized control in all but very few complex systems. Such an approach entails appreciating that only complex open systems operating far from equilibrium can be adaptive. So that's also a positive point, that they can also be adaptive reactive. So depending on the perturbation, they may produce different responses. And observed stability is dynamic in the sense of being continuously maintained, never resulting from reaching equilibrium. Finally, it requires humility concerning our limited ability to represent reality and blatant openness about the incompleteness and provisionality of our knowledge of it. So humility again comes to mind. So when people keep on harping about tipping points and how close we are, I find that humility is often missing there in terms of the incompleteness of our knowledge. Complexity requires us to focus not only on the parts but on the interactions between them. Without such requisite relationality, we can neither succeed in understanding and explaining phenomena nor in improving problems or their definitions. Complexity requires us to do everything we can to remain flexible. But as we discussed in adaptation in detail, you have to have flexible adaptation plans, but some adaptation actions like building seawalls may not be so flexible in reality. We cannot design them to be so flexible. Maybe we'll have floating seawalls and so on. Surprise is inherent in complexity, and we cannot predict what will happen. When also failing to anticipate what could happen out of myriad potential events, you only have our flexibility left, so that you again try to rebuild better, build back better based on what just happened. Complexity requires us to reconsider many of our intuitive measures to reduce risk. Complexity is not only hampering understanding and effective risk reduction, but is generative of disaster in itself, making some disasters simultaneously unpredictable and inevitable. So building on mountain slopes carelessly, for example, can create landslides from heavy rains, but also earthquakes can make them susceptible to heavy rains. So disaster may become unpredictable as well as inevitable. Complexity requires us to consider how effects can cascade throughout the complex systems, regularly ignoring sectorial, political, administrative, organizational, or other boundaries. And epidemic that we had, COVID-19, is one of them, which went across the world and created lots of deaths. Finally, complexity requires us to abandon our intuitive expectations of continuous linear change, as tipping points are equally ubiquitous as unpredictable. So then the main focus has to be knowing them and trying to guess based on early warnings, if any, to see how close or how imminent tipping points may be, but more importantly, how to be prepared for them, which of course depends on resource limitations and other governance and governmentalization issues as well. We must attempt to anticipate tipping points. However, it is best to do everything in our power not to push complex systems we depend on for our survival too far away from their dynamic stability that has proven to be able to sustain us over time. This is again tricky because we don't know how stable the system is, because it has always changed through Earth's history based on orbital forcings and internal feedbacks. Now we have become a forcing ourselves by burning fossil fuels and increasing greenhouse gases and warming, and then the cascades. So how do we know how close we are, or how far we are from dynamic stability in that sense? So we do things like climate sensitivity and so on that try to tell us those things, but it's not always easy. It's essential to understand that complexity is not only debilitating, making effective policy making and practice so much more difficult, it also offers new ways to grasp and address the challenges at hand. Although we can never fully understand how a complex system works, we must relentlessly seek to recognize the nexus of causes and effects of the phenomena of interest, or everything needed to generate a sought after outcome that we define based on our values and so on. A deeper understanding of its interlocking feedback loops may reveal where relatively small investments can generate large outcomes. So a bang for the buck has to be maximized, considering zero resource limitations and the zero-sum game that we are often in terms of priorities. If you put money here, then you will not have money for something else. even though both may be needed. Path dependence does not only pose a problem but provides a possibility for us to have significant influence in shaping, although not determining, future conditions. Self-organization is already essential for social change towards sustainability. Imagine what could happen if the social movement for sustainability reaches that sequence of tipping points just mentioned. When you think about how to improve the world, start making it a better place yourself. It's not a pipe dream of an old environmentalist and a Quaker, it is science. If you are concerned about climate change, make the necessary changes to reduce your carbon footprint, stop flying privately and minimize your business travel, use public transportation for as much use public transport for as much of your transportation needs as possible, and do not own a car if not absolutely necessary. I live without a car, but I take Ola and Uber all the time. Stop eating lamb, mutton, beef and pork, but there are details of cultural values. Plus you need a portfolio, so you can be a vegetarian but driving a big SUV, or you can be riding a bicycle but eating a lot of meat. So you have to be careful about these, single action suggestions. Do not fall for the urge to buy things you do not need. Those are no regret decisions. These are the 4 primary sources of carbon emissions that you could reduce by yourself and save money whilst doing it. Do it. Engage, otherwise others are bound to follow. So peer pressure is supposed to work. Evidence exists. Smoking is a good example. Perhaps enough people will be mobilized also to create the necessary political pressure for meso and macro level changes, perhaps enough to even save the world. But again, I must remind ourselves that we are in a carbon trap, so everything we do now has carbon footprint, so we must actually also move towards making the system carbon free. It's called decarbonizing and net zero, negative emissions, and so on and so forth. Trick of course is that we don't have all the technologies in place, and those that are there, like carbon capture technologies, are not scalable enough. The amount of carbon we actually have to remove from the air is so large, and it's a trace gas, 0.04% concentration, so obviously you have to flow through a lot of air to extract this tiny bit of CO2. So then you have to worry about whether that itself is carbon neutral. Your attempt to capture carbon, is it carbon neutral in itself? But if you're trying to sequester it away somewhere safely for long times, maybe you can do some manipulations to reduce carbon as we go along and as we ramp up renewable energies and so on and so forth. Okay, so this chapter is done now. Next up is governance, governing and governmentalization. Since it's a new chapter, I'm adding the whole chapter to the edition 1 that I had already recorded. Okay.